Today we are going to see the important topic of data structure. So these are the data structure types. So we have a two data structure. One is linear data structure and another one is non-linear data structure. So inside linear data structure we have a static data structure, so which is array, and dynamic data structure, three: queue, stack, and linked list. So when it comes to non-linear data structure, it is tree and graph. So these are the different types of data structure inside the C. So first we are going to see the queue, because we already seen a lot of array, because array also one kind of data structure. So why we need data structure means it is kind of algorithm or a kind of structure to write the code. Um, where, when we have to allow some process, when we have to allow some function, when we have to control the process, control the task, so we need to create some kind of algorithm. So that's where the data structure will play. So when it comes to embedded systems, so you will write some kind of threading, multi-threading, real-time operating system where the multiple process and multiple tasks come into play. Sometimes CPU, so microcontroller have inbuilt CPU, so that will run some kind of processes. So that processes will run some kind of task or process sometimes. Maybe a CPU can only handle some 4 to 5 tasks. Let's assume that if again any other task comes to access that CPU, so that time we need to control the task. So we need to stop the task to process. So until that four task is going to finish. So in that kind of time, we need to do that basic C program to handle that kind of things. Whether that four task is finished, whether if any one of the task is finished, then three task is running in CPU. So that the task which is trying to access that can run kind of thing. So we need to control the logic inside the function. So that time we need this kind of data structure to write it. So this is the one important method, queue method, like first in first out. So that's how it will work. So in if it comes to the embedded system, so whatever the task coming first, so it will allow, it will run. So when it finished, then it will dequeue that allowing process. Then if that available process is count is less than that incoming or running task, then it will allow the new task. So this is the basic concept of queue. So here also we are seeing that we are declaring some macro max equal to 5. Then we are declaring the global variable integer array, which maximum of 5. Then we are declaring two integers with the front and rear. So these are the two tasks. Then we write a enqueue function, dequeue function, and displaying that whatever the function is there, and we write a main queue, main function. So in there we have a four task. Let's say that we have a four task is running. So one by one we are trying to send it. So we are first calling the enqueue function. Then the 10 value will go. So inside enqueue function, inside value, the 10 will be here. Then it will come to this function if. So first of all, rear is -1. So it will check. Then max is 5 -1. So this condition became false because this is not equal. Then it is not overflowing. So we are printing if that maximum, if already the process is done, if already for actually this queue process is not meant to be that contain seeing the process, how many processes are running. So this is controlling how much process run. Sometimes you have to only run 10 tasks per minute or 5 tasks per minute kind of thing. So that logic may change in the application. So now we are doing that now. What our application is that we have to run only 4 4 tasks. So if that task is more, then we don't need to run. So we can tell that it is overflowed kind of thing. So that we need to control. So yeah, now it is under the queue, so we can do this process. So then it is comes to else, then it is checking whether front is -1 or not. So already front is -1, so we can print, we can, this will go to the front 0, so the front became 0 now. Then we are increasing rear plus plus, so rear -1 means it will increase, then rear became 0. Then here it is coming q0 is 10. So q is array, integer array name, then rear is 0, this is the index name of array, then here we are storing, so q0 is 10. Then we are printing the value, the direct value we are printing for our understanding. So we are running the program, so this is, it is printing. Likewise second 20 also coming, so when 20 comes, this became 0, and as usual it will print, so the rear became 1. Then again when it comes, so 1, the third value 30 come, then it will become 2, here it become 2. Then again this 40 is coming, so this became 2, and this became 3. So until 3, the until 40 is printed, so we have entered that. So this array holding the 4 values in the every index 0 1 2 3. Then we are going to the main loop, so it is displaying. So inside the display we are checking whether front is -1 or not. So it will come to q is empty, but our front is already became 0, so that's why this condition became false. Then it is coming to else, then it will directly print the q elements. So inside the for, it is starting from I will start from front, so front is 0, so it is starting from 0. Then this condition will check whether the I is lesser than rear or not. So actually our rear is 3, so 0 is lesser than 3, so this condition will become true. Then it is printing 0. So as you can see 10 20 30, so until 30 it will, until 40 q3, until 3 is coming, because I is 3 and rear is 3, so it will run until rear become 3, then it will print the new line. So until here we run it. Then what we are doing is that we are dequeuing it, so we are going to dequeue. So inside that what we are doing is that dequeue is equal to -1, so this became false, or else front is greater than rear. So yeah, this also became false, because rear is 3, front is 0, so this function will not run. So what we are doing is that else part dequeued from q, so q and front is 0, so it is printing q, then front became plus plus, so front now is that front is 1 now, so we dequeued it. Then again we are doing the display. So when it comes to display, this is false, then I will start from 1, then you can see that this is left that array, and it is printing from 20 30 40. So now we manually trying to overflowing it. Now we are doing the 6 processes. 50 60, now we run. So as you can see until 50 it came, why means, so it is coming here, for 50 it became 3 and it became 4, and another one will come, so 50 will be stored. Okay, then what it will do is that again we are accessing 60. So when we calling enqueuing 60, so this will became 4, this also comes 4, so we already done a 5 task. so we are overflowing it. That's why this printf is printing, then this else part will not do the process, so it will overflow. Then we are displaying it. So if we go to display, the same thing will come, because yeah, the 4 element will come, then the dq element also will print whatever it is in there. Then let's say that we dq, then we are running it. So you can see it dequeued all the elements, then again we are dequeuing it. As you can see, q under uh, underflow is coming. So overflow is that the task has to be 5 task has to run. So even if you dequeued that more than the 5 tasks, it will goes beyond 0, so it goes to minus 2. So again, if you, let's say that for 10 minutes I have to run a 10 task, then after it done the 10 task I have to dequeue it, because all the tasks so first task is running, and that if it is done, then I can dequeue it. So second task is running, like 5 tasks run, finished its running, then I can dequeue it for 5 times. Then what, again after 10 minutes, and again I have to do the 5 task. So if you dequeue it more time, then it will do more task. So that kind of algorithm, if you want to control, this is the main method. So after enqueuing it, we can dequeue it also. This is kind of algorithm to use to control the task, how many times it has to run. So we can use the for loop also in this condition, but yeah, when it comes to the threading, so we have to implement the function like a queuing. So multi-threading means we have to do a lot of process inside the one thread, rather than using, we can use the for loop for the function. So we have to use the function as a for loop. So that time you will understand why we need a queue. So this is the basic function how the queue will work.